Okay, now we're recording. We're hot now, okay? All right. Now, I'm going to explain this slowly so Miss Wood can
Oh, no, I got
let
it.
it. No.
I was in another question.
Okay, now, be quiet.
You're so mean to me.
I know.
That's what she said.
Dependent, independent means with
I know this.
replacement. Now, since we're talking about dependent and independent, this is the multiplicative law.
So independent and dependent, I want to go with that one.
Dependent means without replacement. So when I pick a card, I'm going to put it in my pocket. So which one is this one? It's without replacement because it says not returned. We know that a queen is 4 out of what?
52.
52. How many times are we drawing?
3.
3 times. So that'd be 4 out of 52 times
4 out of 52. 3 out of 51.
3 out of 51 because you're not, what are you doing with the card after you pick it? Put it in your pocket. Times 2. There you go. Now multiply those 3 together. And somebody give me 4 digits. Okay, it doesn't want, it wants type as an integer. Okay, we can. Or a simplified fraction. Okay, let's see if we can simplify it. 3. No, I don't think you can simplify it. You can simplify this, and you can simplify that. Okay, you can simplify this. So let's simplify. 4 will go into 52. That'd be 1 time. And 4 will go into 12 3 times. So that's 1 over 13. 3 will go into 5 1 time. And 3 will go into 21 7 times.
Yes.
And I'll do this one for you. 1 over 25. So 1 out of 13 times 17 times 25. What is it?
5525.
5 what?
5,525.
Now, let's figure out the odds against. Figure out the odds against. You know that 1 out of 5,525 is winning, right? That's success, right? So what's failure?
Not
5,524 over 5,525. 5,524 over 5,525 over 1 over 5,525, and the 525s cancel. Your 5,524 to what? So if you bet a $25 bet, take your 55.24 and multiply by $25.
$138,100.
You walk away with $138,000. But what's the probability of getting 3?
Slim.
Very slim. Okay. That is a test question. It's a good test question. So I'll keep it on the board so Miss Dukes can take a picture of it.
That was ugly. Are you videoing?
Yeah, you're on video now. You're going to be all over YouTube.
All in YouTube. YouTube sensation.
All right, I'm going. You got it?
No, good. Go
Okay.
ahead. It's on video. Don't say my name.
Okay, here we go.
Thing.
Determine whether the following event is independent or dependent. Then find the probability of the event. Randomly drawing and immediately eating Okay, now what does immediately eating mean?
Not get rid of.
Not replacing. A lot of people say, well, it don't say anything about replacing. Okay. 2 red pieces of candy in a row from a bag that contained 10 red pieces out of 43 red pieces, or total pieces of candy. So 10 out of 43 times what?
9 out of 42.
9 out of 42. And how many pieces are we picking?
3.
And then 7 out of, or 8 out of 41. Okay, it's dependent. And what is that probability? It was 3 decimal places. I'll write it on the board so everybody will have it for.
Since nobody wants to participate. I'll-
Exactly, I'll just do it. Okay. So we're at 10 out of 43. That's the first draw. Times 9 out of 42. That's the second draw. And then 8 out of 41. And when you do all of that math, you need 4 decimal places. I want 4 decimal places so I can round. I don't trust y'all. Huh?
0.098.
0.098. She don't listen.
I need another 0. 0.009.
I think I heard only 1 0 the first
It
time.
did.
0.0098. So we punch in 0.0098. Now that's a test question because I want to see if you actually read the question because it tells you what to do. A lot of people, oh, I don't know, it didn't say anything about replacement.
Don't move it, please.
I know, I only threw it up there about 15 minutes ago.
Seriously?
You know, I might as
But
well
it's
forget.
right. I have it right.
Y'all just cannot give me an answer. 0.050 is what y'all supposed to get.
I didn't get there either.
I don't know where that number come from.
Well, then I did it wrong.
It's eating 2 pieces, not 30. You made us do 3.
Oh, well, I asked y'all a while ago how many times we're doing it, and y'all said 3. I'm just going to quit. I'm going to quit asking y'all for help.
0.050.
0. Smart girl.
I'm not asking y'all any more questions. I'm just going to do it myself. And y'all want me to take y'all out to eat? No, there's no way. Y'all would condemn me. Y'all would have me in jail. And y'all would run up the bill like that other class did. $300-something. I took class out to eat, and I had a little bit too much refreshments.
You did or they?
I did. Well, then they started buying, all of them, I checked all their IDs. They were all over.
Everybody's legit.
Oh, I wrote 21.
So are we going out for a party
So
after we
No.
finish
No.
class?
No,
You don't like us to
I
stay
can't do
home?
that anymore.
Why?
People,
Where did
Somebody
you
told
go?
me, right?
you hadn't read, have you read My Professor?
Where did you go
There's
eat?
one person on there said that I made people go eat lunch with me.
Made them? You
Yeah.
don't make nobody do nothing. They don't want to do it.
There's always.
Can you go on there and comment on that?
No. Yeah, you can.
I'm
Okay. You'll have to find it. I don't know where it is. Somebody told me that it was on there.
Yeah,
I made them go eat lunch with
When
me.
did you go, when did
Hold
you
on,
take
where
them
did
out?
y'all go and run up a $300 check?
That was El Patron's.
Good.
I don't
Lord,
like
that's
Mexican.
cheap.
There
Let's
was
not go
like
there.
25 of us.
No, not El
Tequila.
Patrons. I don't like Mexican.
Oh, well, they're very generous with their refreshments.
Yeah.
I don't like
American restaurants are not very generous with anything.
Nice.
Chili's. Give good refreshment.
You're on the top.
You've never been to a Mexican restaurant.
No.
They bring them things,
They bring
especially if
all
you're
the
Famales.
tequila.
The Famales, they get all the free drinks.
You know that you're one of the top teachers here on Rate My Professor?
No, I didn't know that.
Top, is it top? Oh,
Okay, randomly
So
selected a
that deserves
four-person
us going
committee.
out. You just got that information
So
from this
Wednesday, we're
class.
going to Olive Garden.
Wednesday, no class.
Here we go. Determine whether the events are independent or dependent. Then find the probability. Randomly selecting a four-person committee entirely of men from a pool of 16. Oh God, here it goes. Very sexist. All right. Is this bodies or votes, or is it, what is it? It's bodies, Hubert. Yes, it is. It's bodies. What did I tell you about bodies and votes?
now vote again.
They're automatically without replacement. Why?
But you can't replace somebody or something.
And you can't vote what?
Independent.
Unless you're in presidential election. Mickey Mouse voted in Illinois. So, would this be dependent or independent?
Independent. No, really?
Dependent, without replacement. Anytime you're dealing with a vote, or if you're dealing with a body.
What's after that? Vote or body? What's the answer?
Dependent.
Dependent.
All right, so how many men are there? I mean, how many women and men are there? 28? So this is going to be, how many? 4? So it's going to be 16 out of 28, 15 out of 27, 14 out of 26, 13 out of 25. I'll write it down.
Did you add those numbers together?
I don't know. Last time I checked, when we had dependent and independent, what does that mean? Multiplicative law, Hubert. That's right, class.
16.
Y'all just ignore everything I say. That's okay. 28. Y'all suck. Let's see. All right. So 4 out of 16. I'm sorry, 16.
See, there, I was getting ready to say it should have been.
I know, you were getting ready to say it. I know. 16 out of 28. 15 out of 27. 14 out of 26. And 13 out of 25. And somebody give me that to 4 decimal places. Three days later,
You said 3?
4.
4.0889.
I hope you're not leading me astray.
I'm not even there.
I feel good about myself, so I don't have to put smokestacks on my truck.
I have to put what?
Stacks on his truck. Little man, big.
It's little man syndrome.
Makes you feel better about yourself.
Okay, this one, you have to do a sample space.
According to
Sample
this, you're like-
space. I'm trying to find the button to erase. There we go. Determine whether the following events are overlapping or non-overlapping.
That's
Overlapping.
what I was talking about, Walter.
Additive law. This is the additive law. Then find the probability of the event getting the sum either 3, 10, or 11 on a roll of 2 dice. So work it out. If you can't work it out, just consider yourself a failure. Good job. What?
Yeah. So I can get some sleep there.
I'd say it's not overlapping. Because there's only, and once you draw them out, you don't have to draw out all of them. But you got 2 die, right?
Yes.
Accidentally hit the freeze button. So here's your 2 die. Now how can you get a 3 with 2 die?
2 and 1.
A 1 and a 2 and a what?
3.
2 and a what?
1.
1. Is there any other way to get a 3?
No.
Okay, so we're done there. Now, 2 die. And we're going to get a 10. Well, let's start with 1. Well, 1 and 9. No, you can't do 1 and 9 because there's not 9 on them. So what's the first one you can do?
4 and 6.
4 and 6. And 6 and what?
4.
4. What else?
5 and 5.
5 and 5. Anything else? 5 and 5, and then 5 and 5. I don't know if they're going to count that as 1 or not. I don't know. We'll have to see about that. I think it's 1. And then what's the last one? 11.
6 and 5.
6 and 5, and 5 and 6. So 1, 2, 3, 4, 5, 6, 7. Okay? So there's 7 of those. So how many rolls can we get out of, let's see, there's 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. So there's 1 in these, 2 in these, 3 in these, 4 in these, 5 in these, 6 in these. So 6 times 6 is what?
36.
So each one of these has a chance of 36 different things coming out, right? Okay, so how many is this? 2. 2 out of what?
36.
How many? 3 out of 36. And 2 out of 36. Now I'm going to keep a common denominator because
7.
make it easy. So 7 out of what?
36.
And now you take your handy dandy calculator and do 7 out of 36, and what does that give us?
0.19.
That should be your answer.
And there's no overlapping, right?
Because you don't get,
Over 1.
yeah, there's no overlapping, yeah. So I put in my handy dandy number of 0.19, and if you did the calculations right, which you did,
How many decimal places
Forget
is
it.
it asking?
just forget it.
Oh, it's asking for a fraction.
7 out of 36, so I would take either answer. Because it really doesn't tell you, oh, there it is. Type as an integer or a simplified fraction. I didn't see that. Question. You know I'm doing y'all's homework for you?
No, you're not, because it's not the right question or the right. So-
Determine whether the following events are overlapping or not overlapping.
Well, it's not.
Then find the probability. Draw either a black 9 or a red 3 on one draw from a regular deck of cards. Okay? Work on it. Drawing either a black 9. How many black 9s are there?
2.
How many red 3s are there?
2.
Okay. And there's a or there, and it says overlapping. So what does the word or mean in overlapping? What law?
Additive.
Additive law. So 2 out of 52 is the same thing as 1 out of 26, right? So it's non-overlapping because they can't occur at the same time. So it'd be 1 out of 13 plus 1 out of 13 is what? 2 out of 13? Did I not? Let's see. 2 out of 52. 26.
Yeah.
Well,
I
2
got
out of
113,
26, which is 1 out of 13. I'm sorry. 1 out of 13. Okay. So that's a good test question.
So the answer was
1 out of 13.
We're not seeing.
I'm sorry. Oh, I'm sorry. What does this one say? This one says, find the probability drawing either a black 4 or a black king. Well, that's the same thing. No, you don't have to do that one. We're going to move on to bigger and better things. All right, try this one. Determine whether it's overlapping or not. And then, what is the probability of either a non-face card or a jack? Now, how many non-face cards are there?
There's
10. There's 10 per trick, or 10 per suit. So that'd be 10 times 4 is what? 40. And how many jacks are there? 4. Shouldn't have bought those donuts this morning.
What are you rambling about?
I don't know. You know what men do, we just ramble. Non-overlapping. And that would be,
11 over 13.
well, I'm trying to write it down for y'all, but you want to go ahead and get to the answer. So. Now, wait a minute. Yeah, 10 out of, so 10 times 4 is 40 over 52, right?
Yes.
And this is the additive law plus over 52 is equal to 44 over 52. And it wants a fraction, so we got to simplify. So I think we can both divide these by 2, and that would be 22 over 26. And divide by 2 again, they know 11 over 13. I get 11 over 13. What y'all get?
Me too.
You think they gonna bet on that in Vegas?
Yes.
No, they ain't. Why? Too easy to win. 11 out of 13 is too high. Somebody do the decimal on that. What is that?
It is 0.85.
Vegas don't like 0.85. Vegas likes 0.0085. They like the round zero. So you might win a nickel off of this game. All right, at least one. This is very important. Use the at least one rule to find the probabilities of the following events. Getting at least one tail when tossing 8 fair coins. Now, I want you to ask yourself this, that means mentally, what at least one means. And I tell you to draw a number line. Draw a number line and put 0, 1, 2, 3, 4, 5. And say, what does at least one mean? Just think about it. And I'm going to do that with you because at least one is very important for later on, especially the test. Because there will be test questions on the test that says at least one. And at most one. So we're going to talk about that right here, right now. I hit you twice. Okay, reading from left to right, what does at least one mean?
One or more.
That means your lowest number is what?
1.
So that means if your lowest number is what? 1, that you're looking to the what?
Right.
To the right. Now you'd be surprised at how many people go through 12 years of school and don't know what at least one means. Same thing with at most one. If I give you at most one, what does that mean? That means that your largest number is what?
1.
So that means everything to the what?
Left.
So that means 0 and 1. So at most 1 means 0 and 1. At least 1 means 1 and what? More. Now this is very important. I'm going to take my red. I don't like to write in red. But you need to put that somewhere in your notebook, and you need to make sure you know it before the test because that's important. So, this thing, use at least one rule. I just showed you at least one rule. Getting at least one tail when tossing 8 fair coins. So you've got 1, 2, 3, 4, 5, 6, 7, 8 coins. And this says getting at least one. So that means at least one means what?
1 or more.
1 or more. Now, when you flip a coin, when you're doing these flipping a coin here, you got to think to yourself, okay, you're flipping this coin, you're flipping that 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 coin. So you've got a probability of 0.5 per tail. So the probability of tails is 0.5. So that means that I'm going to add 0.5 or multiply 0.5. Well, what happens when you add 0.5 and 0.5?
You get one.
And what can you not have in probability?
One.
So you're not going to use the additive law. So that means what?
0.5 times.
To the, how many? What? To the what?
To the 8,
Okay, at least one means here,
7.
7. So what's that? Somebody give me that number.
0.00.
Okay, it says, wait a minute. It says type as a simplified fraction. So that would be 1 to the 7th power over 5 to the 7th power, and or 2 to the 7th power. 2 to the 5th power is 64, or 32. 64, 128. So it would be 1 over 128. I'm thinking in my head. 1 over 128. Okay. Then we need to do 0. We need to do the probability of 0. I'm sorry. Probability of 0. My bad. So the probability of 0 tails would be 0.5, right? It should be what it is. Yeah. 1 minus 0.5. But this would be 1/2 to the, okay, 1 minus, okay, I did it backwards. What's 1 minus 1 over